Take a look at number 13, P upon Pm minus Pt. Now this looks similar to us to a previous question, question number 11, where we had Pm upon P plus 2. Yeah, and what we said was that we cannot cancel this P with P, the P down here, because if you remember, we said that we took the example of numerical substitution, that Pm is being divided, Pm is being divided by this entire term. Similarly, what we might say is that P is being divided by this entire term, so the P's don't cancel. However, if we modify this a little bit, we will get P divided by P times M minus T. I don't know if you can see this. I have taken P common to this. P times M minus T. And now what I get is, we have P in the numerator and the entire denominator, not the entire, this part of the denominator is being multiplied by P. The rest of the denominator is being multiplied by P. Therefore, rather than multiply this by, have P in the numerator and then multiply the denominator by P, we can actually cancel this. Why? Because we could take P common outside the subtraction. The entire subtraction is being multiplied by P. So then we can cancel it and our answer comes 1 upon M minus T. If you are doing a cancellation like this, remember it is most important for you to show this middle step, okay, so that you also don't make any mistakes. Let's move on to the next one, which was P plus M upon P plus M times P minus M. Now in this case, like in the previous case, it is clear that we have P plus M in the numerator and this half of the denominator is being multiplied by this term. So rather than have it in the numerator and multiply the denominator by that, it is possible to cancel these out and we will get 1 upon P minus M. Let's come to the next one, which is P upon P plus M into P minus M. So now, in the previous case, we had P plus M in the numerator and P plus M in the denominator. Now we have P in the numerator. We do have P in the denominator, but P is being added to M and M is being subtracted from P. This is not just P alone. So can we cancel it? If you come back, if you remember question number 11, since there is an addition, we cannot cancel it. So what can we do? Can we open the brackets and try? Let's try. What happens if I perform this multiplication? P times P is P square. Oops. P times minus M is minus MP. M times P is plus MP. And M times minus M is minus M square. Now I will get P upon P square minus M square. Can I cancel these? No, because it is being divided. The denominator is P square, is M square less than P square. So until we perform this, there is no cancellation or calculation that can take place. Let's take the next one. P square minus M square upon P plus M into P minus M. Now again, there doesn't seem to be anything we can cancel over here. P cannot be cancelled because there is an addition. M cannot be cancelled for the same reason. So as such, it doesn't seem like there's anything to do. But if we do solve it, if you notice, this denominator is the same here. So if I do open up these brackets, I will get this P square minus M square. So I get P square minus M square in the denominator and P square minus M square in the numerator, and then of course they will cancel. Okay, so that does it.